Okay, so we're going to start with two positive charges. One is 2 nanocoulombs and the other is 8. And they are 4 centimeters apart. So the first part asks us to find the magnitude and direction of the two forces on each. So they're going to be in opposite directions. So this is the force of 2 on 1, and this would be the force of 1 on 2. So the force equation that we want to use is KE Q1 times Q2 over R squared. So when we plug it in, we have the force of 1 on 2 is equal to 8.99 times 10 to the 9th times 2 times 10 to the negative 9 times 8 times 10 to the negative 9 all over 0.04 squared. Make sure you convert the centimeters to meters. And then when you multiply that out, you get that the force is 8.99 times 10 to the negative 5 newtons. And this would be the same force for 2 on 1, just in the opposite direction.
Alright, so for part B, our answers for A make sense because if you think about how opposite charges attract and like charges repel, so since we have two positive charges, the forces are going to go out in this direction. And then this one is going to be to the right and this one to the left because we defined our coordinate system as this one at x equals 0 and this one at x equals 4. So this force is going to be going in this direction while this one is going in this direction.
Alright, so in part C, we were asked to find the electric field felt by each charge, and we were asked to find the magnitude and direction. So firstly, if you look to the force equation, you can find that, let's say we're doing F1 and 2, so basically this is the force felt of this charge by this one. So Q1, this is F1 on 2, Q2 all over R squared, and then we look at the electric field equation, it's actually, because this is the electric field that this charge is exerting on that one. And so if you take these two equations, you come to electric field is equal to magnitude of the force all over the point charge, which in our case is actually the point, or the Q2. And from here, you can see that if we take our force from part A, we go 8.99 times 10 to the negative 5th divided by 8 times 10 to the negative 9. This point charge right here, you get 1.12 times 10 to the 4th newtons per coulomb. Alright? And again, that was like the electric force charge felt by 2 from 1. And then we come over, we're going to go to this force, so this is the other one. We have now the electric force felt by 1. And then we have 8.99 times 10 to the negative 5th again, all over, except this time it's 2 times 10 to the negative 9 equals 4.495 times 10 to the 4th newtons per coulomb. There you have it.
So for part D, our answers make sense because electric field lines generate from positive charges. So they're going this way, this way, this way, all around it. And so this first one makes sense. This is the electric field that this force feels based on this electric field. And then the opposite is true for this one. So this is the charge that gets being felt by this electric field with those same lines coming out of it. And so an electric field and the force point in the same direction because they're positive charges.